The air-sea interface varies quite significantly from this sort of beautiful calm picture you see on the left to this very extreme rough picture you see on the right. Now, this movie on the right actually comes from the sea trials of Australia's national research vessel, the RV Investigator, in the Southern Ocean. And this sort of rough sea surface is quite typical in the Southern Ocean, where you have very, very strong winds. Now, of course, the nature of the sea surface, whether it's this smooth, flat surface or this very rough surface, of course, influences the air-sea fluxes that occur at this interface. So let's imagine a very simple schematic of the ocean surface and think about the fluxes that occur across this surface. So the first main one we have is, of course, heat. And this is crucial in the climate system because the ocean is absorbing over 90% of the anthropogenic heat. So it's only because the ocean is absorbing so much that our climate in the air, our atmosphere, remains a lot cooler than it would otherwise be. So the ocean is performing this crucial service in the climate system. The next major flux we need to think about is the flux of water or moisture through the sea surface. So 80% of global rainfall occurs over the ocean. And indeed, most of the rainfall that we get over land, in Australia in particular, comes from over the ocean. So this sort of water flux that occurs through the sea surface is crucial to our water resources and floods and the climate system generally. The next flux is, of course, a flux of carbon that occurs through the ocean surface. So the ocean is currently absorbing about 25% of the excess carbon emissions that we're putting into the atmosphere, which again is reducing atmospheric concentrations and therefore keeping the climate cooler than it would otherwise be. And finally, there's a very important flux, which is the flux of momentum. So essentially you get the wind, which blows over the ocean surface, and this causes a drag on the surface and pulls the ocean surface along with it. And this is crucial in forcing the ocean circulation, which then has feedbacks on the other fluxes because it changes the storage of heat and carbon in the ocean and therefore influences the climate system. So these are the four main fluxes that we're going to discuss in this next little segment of the course. As I've already mentioned, the ocean surface is so crucial because it's through this surface that the ocean and the atmosphere are coupled together. So when we talk about the coupled climate system, primarily we mean how the ocean and the atmosphere communicate through the ocean surface. Now, in addition, there is a contribution from the land surface as well, but that's relatively smaller. The two primary components of the coupled climate system are the ocean and the atmosphere, and this all happens through the ocean surface. So it is a very crucial region and a crucial part of the climate system that we need to understand.